Hello everyone and welcome to the last lesson of the school year. Today we're talking about dilations. We have talked about this before, so this whole lesson is review, but it never hurts to get a good refresher on something that often you use, whether you realize it or not in this case. A dilation is a transformation that changes the size of a figure but not the shape. So we have the picture on the left that shows a dilation, and on the right where it's not a dilation. So if you look at the not a dilation, you can tell that these are two different shapes. They're not drawn to scale. A dilation has to be to scale. So the length of each side of the triangle should be in scale proportionally to the sides of the larger triangle. One example of where you may have seen a dilation in the real world is every time you are on the computer and let's say you're writing a paper and you need to put an image in your paper. It often pops up in a text in a little image box like this, and it has points for you to click on to drag the shape to be larger or smaller. If you are pulling by the corner, you are making the whole shape go to scale. But if you were to only pull on one side of the shape and nothing else, that's not a dilation. So a dilation is only when you're using the corner to stretch your picture. A dilation is a transformation in which the lines connecting every point A with its image A, the new A, all intersect at point P, called the center of dilation. So our shape is growing from point P. So the distance from the original B to the new point B will be to scale with the distance from the original point A to the new point A, all coming from that center point P. Three main points you need to know: the shape changes in size, all angles stay the same, and side lengths are proportional. We will be looking at two different types of dilations in the coordinate plane. If our scale factor is larger than 1, scale factor k, larger than 1, our shape will increase in size. If our scale factor is less than 1, our shape will decrease in size. To graph the new shape, it's quite simple. Just multiply the coordinates by the scale factor. That's all you need to do. Those are your instructions. It's shown in the point here where we have k. K is a constant. K times x is the new point. And that works for both increasing and decreasing. So let's go ahead and look at a couple examples. Draw the figure JKL in the coordinate plane below. Then dilate the figure about the origin by scale factor 2. Label the coordinates of all your points on the plane. Alright, so I've already gone ahead and drawn the figure, and so I plotted my points and connected them. I'm going to go ahead and list out my points on the side so I can show my work. So I have J at the point 0, 0. I have K at the point negative 1, 2. And I have L at the point 3, 4. All right, so we are increasing by a scale factor of 2. So I'm going to take the x and y from my point and I'm going to multiply them by my scale factor, which is k. So in this case I have k is equal to 2. And my new points are going to be kx and ky. So my point J, I have 0 times k, which is 2. 0 times 2 is 0. Y happens to be the same thing. 0 times 2 is 0. So my new J is at the point 0, 0. All right, my point K, I have x of negative 1. Negative 1 times my scale factor of 2 is equal to negative 2. I have my y. We have positive 2 times scale factor of 2 is equal to positive 4. So my new k is at the point negative 2, 4. My point L, I have an x of 3. 3 times the scale factor of 2 is equal to 6. My y of 4 times the scale factor of 2 is equal to 8. So my new L is at the point 6, 8. Now I'm going to go ahead and plot those points. So my J happens to be in the same spot, so that's my new J. And we are dilating from the origin, which means that my line that the shape is growing on is going to be consistent for the line JK and the line JL because it's stretching from the origin, which is where point J happens to be. So I have K at negative 2, 4, which is up here. That's my new K. And I have my new L at the point 6. So we're at 2, 3, 4, 5, 6, 8. 1, 2, 3, 4, 5, 6, 7, 8 is up here. So that's my new L. I'm going to connect my points. And none of these lines are going to be all that straight. I apologize for that, but you'll get the point. And that is my dilated figure. It had a scale factor of 2, so I knew that my shape should have been doubling in size. Example 2 says, draw the figure A, B, C, D in the coordinate plane below. Then dilate the figure about the origin by a scale factor of 1/2. Label the coordinates of all your points. Alright, so I've already drawn the picture. Let's go ahead and list out our points over here so we can show our work. So I have A at 2, negative 2. I have B at 2, 3. I have C at negative 3, 3. And I have D at negative 3, negative 2. All right. So we are dilating by a scale factor of 1/2. So let's go ahead and make note that we have K is equal to 1/2. And I'm looking for my coordinates Kx and Ky. Alright, so starting with point A, I have my x of 2 times my scale factor of k, which is 1/2. 2 times 1/2 is equal to 1. I have my y of negative 2. Negative 2 times 1/2 is equal to negative 1. So my new point A is at the point 1, negative 1. Alright, B, I have an x of 2 times 1/2 is equal to 1. And my y of 3 times 1/2, when I multiply that across, gives me 3 over 2, which is equal to 1.5 as a decimal. So we're going to use the decimal from this point on. So my new B point is at the coordinate 1, 1.5. C, I have an x of negative 3 times 1/2, which means that I have the same response from before, but now I have negative, so I have a negative 1.5. And my y is at the point 3, so I'm going to multiply that by 1/2, and that gives me a positive 1.5, which means my new C coordinates are at negative 1.5, positive 1.5. And my D, the x is at negative 3 times 1/2 is equal to negative 1.5. And my y is at negative 2 times 1/2, which gives me negative 1. So my new D is at the point negative 1.5, negative 1. All right, let's go ahead and plot those. So my new A is at the point 1, negative 1. So I'm moving in, which would make sense because my figure is shrinking. My new B is at the point 1, 1.5. You're going to want to be careful here. You want to get about halfway between those two lines. Letter C, yeah, a little trickier yet because we have two half of a point. So I have negative 1.5 and up 1.5. So I'm directly in the center of this cube there, that grid. So that's my new C. And my new D is at the point negative 1.5, negative 1. That's my new D. And now let's go ahead and connect the dots. And that is my dilation by a scale factor of 1/2, which again means that my shape should be half the size of the original. All right, that is where we're going to stop for today. You may have noticed that there's one more page and it has this example here. We've previously done this example in a different unit. It was a challenge question. Because we've looked at this one before, we're not going to look at it again, but I wanted to give it to you guys in case you have interest in continuing with this lesson and looking at a little bit of a deeper level of what dilations can do. If you do have an interest in that, the link that is shared on the page here, it's a Khan Academy link, will be really helpful in helping you learn how to dilate when your center of your dilation point, your center of dilation, is not on the origin. And that is the end of our final lesson of the school year. I hope you guys have a wonderful summer. If you have anything that is not turned in, this Thursday, June 4th, is the absolute last day that I can take anything from you, whether that be test corrections or if you have missing homework assignments. Please make sure you're getting those in at the end of the day on Thursday. It will be too late to turn anything in, and your grade will stay where it's at for the whole school year. That will be your semester grade.